Hopefully this will be something just a little bit different and something you don't often see at these meetups, but we'll start at the beginning. Who is this guy and why should I listen to him? My name's Paul. I am currently a React Native engineer working for a company called Anaplan. I've been doing React Native there for about a year and a half, but my background is mainly in kind of server-side Java and that kind of thing. So I'm fairly new to React Native, but I've been a JavaScript evangelist, for want of a better word, in my own spare time for a long time, and I really love working the language. And this is my cat Solomon. More about him later in the talk, but he does come up. So I want to talk about a few topics today. It's just things that I've played around with in my spare time over the last year, because a lot of what we do and a lot of the engineers here who work in React Native do is get paid to write apps for businesses. And, you know, there's a lot of forms, there's a lot of showing graphs of energy usage and other things, which is really useful, and we can make that really entertaining and interactive. But there's so much more that we can do with this library, this ecosystem, and a lot of it can be a bit of fun. And I want to kind of dive back to a little bit of mobile history and talk about skeuomorphic components quickly. So a quick recap of what is skeuomorphic? What does that mean? Weird word. It is when something in software mimics a real-life object. And the reason why you saw a lot of stuff about this a few years ago was when the iPhone came out, when the iPad came out and things like that, there was a resurgence of using skeuomorphic design to convince people who knew how to use, a real-life radio that they could use one on this weird flat pane of glass because it looked kind of similar. There was a knob there that they could turn and that would change the radio station that they were dialing into and things like that. So really useful for migrating people into this concept. And that concept has been used before. So if we jump back to some of the early desktop computers, things like the trash can that you see on the desktop of a Mac or a Windows PC, that was there because they wanted to say this is how you delete files. You literally drag them over and throw them into the trash can. But nowadays we don't see this kind of thing very much because flat kind of designs have taken over. People know how to use tablets. People know how to use smartphones. So there's no need to have that skeuomorphic element anymore. And it does get in the way. It does cause a lot more clutter because there's a lot more design to it. But, that's quite nice. That's quite elegant. And there is an elegance to it and some fun as well. I remember when I was a kid on my Mac Plus, I installed an add-in that made Oscar the Grouch jump out of the trash can whenever I threw something away. Cue, 8-year-old me making empty files and throwing them away just to see this little Grouch happen. So you can have some fun with it and really inspire people to kind of think about things in a different way. So I wanted to use some skeuomorphic design in an app, and I kind of went around this the backwards way. I went, what kind of an app can I do that would use some fun components? And I play tabletop games with giant clanking robots that are little models that run around on a table. And I wanted to make an app for me and my friends so that whenever one of these clanking robots would kind of charge at one of the other ones, you could push a button on an app and just make a sound, a giant kind of war-horny sound coming out of your phone, just to kind of get us into the depth of the game. So something silly for me and my mates. And I wanted the buttons in that to, as I say, look like they were something that you would find in the cockpit of one of these giant clanking robots. Also to look a bit like an arcade controller because that's the kind of stuff that I'm into and I like. So here's a really simple idea for a component. We've got a button with two positions, an up position and a down position, and we can see, it's just really two images. So fitting that into being something in React Native, not too difficult. And we can have a look at some code here. Where hopefully you can read the code and it's not too small. We've just got a normal image for our down version of our button, which we're rendering there, and it's in place and sitting there and looking pretty. And on top of that, hopefully, we're going to position our up version of that image. Now the up version is absolutely positioned here over the top of the down one, but its opacity is set to 0, so that by default, it's going to be invisible. And then we're wrapping that all in a touchable without feedback, which, when we press it, is going to change that opacity so that the up other way around, the down button becomes visible. I got my opacity is the wrong way around. So we're hiding one image that's placed over the other just to kind of trick what we're seeing into feeling like something's going up and down, and you can kind of see what that looks like here. And it's actually really quite nice feeling when you kind of hitting that on a phone and feeling that kind of arcade button push. And you can even add in a little bit of haptic feedback there to really make it feel like you've got this little button clacking up and down. So that's a really simple example of something that you can do. But I wanted to go a bit further and do something a bit more fun. I wanted to have this idea of big levers. If you imagine someone inside, again, one of these cockpits of a big robot pulling this lever down. But I wanted to make it, simple, easy to use. So just something which, when you tap and hold, the lever goes down, and when you release, it kind of snaps back up. And the idea of it snapping back up was quite important to me as well. I wanted it to feel like when you tapped and held that lever, it felt like it was straining to come down, like there's some weight behind it. So in order to kind of build this up, and I wanted to do it with, the really basic components that we find in React Native. I wanted to do it with just, views, images, and some animations. So I was using the animations library straight out of React Native. Just quickly, how many people here have used animations in React Native or the animations library that comes out the box? Okay, that's a good number. I'll just quickly run through the kind of the core concepts or the core bits of that. Everything revolves around animated views and animatable components. Animated values and animatable components. So an animated value is a special value, so normally a number or something like that, that you can attach to one of your styles in an animated component. And as you change that value, you don't have to go through the full re-render cycle in React to change the style in the component. So animatable components can take these special animated values and change over time. And the way you control that time is by using an animated timing, which when you call a start on it, you can say, I want to do, change this value from 0 to 100 over a period of, 2 seconds or something like that. So you change the position of something over that time. And the last aspect to mention here is interpolation, the idea that you can take an animated value and map it to another value. And this is really important because it lets you drive lots of different things in the app from one animated value being changed over that period of time. So let's break down this lever and look first at the ball that's on the end of it. I want to imagine that there's a box around that, and when I press and hold, I want that lever head to drop to the bottom of the box. And then when I release it, I want it to go back up to the top. Simple enough. So I need to have some kind of value that's going to take me from this position at the top to this position at the bottom. So I know what my start and end values are going to have to be. There's another aspect to this, and again, this is me thinking about the skeuomorphic aspect and saying I want this to feel like, you're pulling this lever down inside this dark cockpit of this robot, and there's spotlights everywhere above you, and as the lever head is going past one of those lights, you see the reflection in the light changing where it is over this ball. So what we're actually doing here is rotating the ball by 70 odd degrees to make it feel like that light source is changing its position. And of course, as it comes back up, we need to rotate it back. And this is where some of the interpolation comes in, because I want to drive all of this from one value. So again, let's have a look at a piece of code. I'm going to initialize this animated value at the top here to begin with a value of 0. And then I'm going to declare an animation that over the duration of 1,000 milliseconds, so 1 second, it's going to change that value to being whatever my max height is. So that's the distance that I want to move the ball down. And I'm also going to set up another animation, another animated timing that is going to have that flick back to 0, but this time over 500 milliseconds. So again, I want that to feel snappier on the way back up, so you've got that feeling of weight and then the spring back up of the lever. And finally, I want that rotation to happen. I do that by interpolating that same ball position value that I'm driving. So whether it's going up or going down in value, I'm mapping that to a number of degrees between 0 and 70, so we get that rotation. And we can see what that looks like in this animation here, and you can kind of feel that light source. It's tricking you into feeling like it's, you're moving past the light source when all we're doing is applying a little rotation to it. So great, we've got an animated value going, we've got the head of the lever going. Let's talk about the lever shaft. And in this case, I've got started with the animation to give you an idea of what's going on here. We're kind of really shrinking it and then making it grow back down at the bottom. So really, we've got two images here that we're using. And you'll notice that, again, the bottom one is rotated around so that the shiny part is on the other side. So again, so that you get that feeling of as it goes past the kind of the where you're looking down straight on it, that feeling that it's gone past a light source. There is a bit of an overlap there where you've got one image that's shrinking almost to zero and the other image that is growing, and that's kind of a bit ugly, but fortunately for us, the lever head is going to be above that point. So as we go through that shrinking process, that lever is going to be hiding any nastiness there, which means that we can get away with being quite simple about this. And the idea again here is to use just the basic APIs that React Native gives us. So again, a little bit of code here, and you notice that this is really just doing some interpolation off of that original ball position. We're just saying when the ball position gets to halfway down, so when it's over the top of that small section, we're going to interpolate the top part, the lever being up to being down towards zero. And then we're going to do the opposite for the one at the bottom. It's going to interpolate so that when it's from that midpoint, as the interpolation takes our lever height to being, or the ball position to being at the very bottom, this one's going to grow, and it will do the inverse again because the interpolation gives us that for free. And I'm going to also show you here, we can start to build up the actual animated images into our tree now, starting with the lever up, then the lever down, and then the lever head at the bottom. And you can see where I'm actually using those interpolated values, or in the case of the ball position, the actual animated value at the bottom there. It's worth noting that the lever head has to be the last thing that we're putting in the DOM here, because we want it to be rendered on top of all of the other components. So hopefully nothing too kind of crazy going on there. It's all just using very basic React Native APIs. Just the last quick thing on this. So we've got the base at the bottom of the lever, and we need to rotate this by 180 degrees at the point at which the ball head is going to be over it. So again, this rotation gets hidden by the ball head being over the top of it. But it's a slightly more interesting interpolation because we want it to be very sudden. We don't want it to be a smooth translation. So in this case, my interpolation here, I'm saying I want you to go from 0 degrees to 0 degrees for the first half of the animation, and then suddenly flip to 180 degrees and stay at 180 degrees until the end of the animation, and again vice versa as the animated value comes back up again. So we get that sudden flip at the halfway point. And then our animated image that would again just go into the DOM, it would have to go above the lever head, because the lever head again needs to go over this. And that's what it looks and kind of feels like when it's actually working. So you get the feeling of this lever that as you hold and tap down on it, it pulls down, and as it flicks back up again, it looks like it's moving past that light source. So just something a bit fun, a bit cool, probably not something you're going to see in very many business applications. At least I kind of hope not. This would be pretty awkward to use in anything really serious. Cool, so who remembers why I started doing these components in the first place? Anyone? I want to make sounds. It's supposed to be a soundboard app. Why did I get so sidetracked with making these silly components? So let's talk a little bit about audio quickly. So I did this app using Expo because I really like Expo. I really rate it as a framework for building React Native apps. If I can use it, if I don't need to reach for APIs outside of it, I do. It gets me started really quickly, and I love it for all of these reasons. However, I did find when developing the audio for this that it doesn't really provide me as fine a grained control as I really need for doing this, and there are some issues on Android, so bumping up against some of those edge cases. But I'll quickly take you through playing audio, and this applies in quite a lot of frameworks actually. So when I did audio in kind of Java Swing 10 years ago, there were a lot of similar concepts. And unfortunately, a lot of the API's documentation doesn't tell you what order you need to do stuff in, even though the documentation is really good. So I kind of had to stumble around in the dark a bit while working this stuff out. So the first thing you need to do before you even get to take that sound file and get it to come out of the speaker is to set the audio settings for your app. And these can be quite exclusionary of each other. So you need to read the documentation for that quite carefully, select the settings that you want, make sure, you don't care about recording. Do you care about, the app being able to play when the app goes into the background and things like that? Things that you can imagine a regular audio playing app might want to do, whereas this is a silly soundboard and I don't really want it interrupting, people's phone calls. And then we need to preload the sound, because when you tap on a button and you want a sound to play, you don't want to wait a few seconds while that sound gets loaded into memory and then plays. You want it to feel snappy, and when I hit that little arcade style button, it just plays the sound. And finally, we can play the sound, but there's this other concept that you need to think about, and that's rewinding, because generally in a lot of these APIs, you play a sound, you have a position in the sound file where you are playing to, and unless you tell that explicitly to go back to the beginning, when you play the sound again, it'll try and play from the end and you won't get any sound, which is really annoying to debug and work out why your sounds aren't playing after one hit. So let's break this down a little bit and look at setting up the audio settings. And again, we're talking about Expo AV, so I import that, and then I just pick the settings that are correct for me. I'm not going to go through these, but it is things like here saying, play in silent mode in iOS, so if someone's got their phone muted, it's a soundboard app, they probably actually want to play the sound, allow it to play, and things like that. The only fun setting there is the, oh no, there's supposed to be a little emoji of a duck there, it doesn't come up. You'll have to trust me. Should duck Android, entertainingly named, that is should the sound lower if another app plays over the top. So if your alarm that says your pizza's done goes off, do you want that to be louder than your app? Well, probably. This is, again, a silly soundboard app. I don't want it playing over other things. So then we can talk about the other three things, and I want to deal with them all together because I really think that we want to, as developers, think about them as one unit of work, one thing that we want to happen. So I've wrapped this up in a kind of a convenient function called, create sound. And this is something that I would expect to run, during the splash screen of the app or something like that. We want to be able to load up the sounds and get them ready for playing while the user is, distracted by some funky splash screen or something like that. So I'm going to wrap everything in this convenient function, which is going to take the audio file or asset, and because it could come, from the web or something like that, I guess. And it's going to load it up, and we're going to wait for that to happen while it's happening. And you can actually pass in some extra options here as well. So in this case, this was me trying to use the Android Media Player to see if I could get some bugs that I had with playing on Android worked out. And then finally, I'm going to return a little object here with a play function that is going to both do my playing of the sound and reset it to 0. So before I ever play the sound, in this case, I'm going to be resetting it to position 0 and then playing through. You don't necessarily always want to do this. You might want it to be that, for example, if I try and hit a button twice, it continues playing, the sound all the way through just once. And it'll only allow you to rewind, once it's played through and finished. But in this case, I went for a simplistic approach of if I mash a button 5 times, it's going to start it 5 times, stopping each of the prior ones and moving back to the beginning. I did mention that there are problems with Android with Expo AV. The problem I came up against was it was actually using the wrong volume control for a lot of Android devices. In fact, when I gave this to my friends who used Android devices, their up and down volume buttons were changing the system volume, while obviously the media volume was for the app was what controlled the audio of the file in the app. So they couldn't physically change the volume of that without having to go into their system settings to change the volume for their media settings. And that was kind of a really rubbish experience trying to tell each user, no, you have to go into your system and do that. And Expo AV doesn't expose the various volume controls to me. So it was just a bit frustrating. And if I want to take this app forwards and really do anything with it, I'm probably going to have to eject, which is always a sad moment for me with Expo, but sometimes it's necessary. I think I've got time to do one more segment on this, and I'm going to talk a bit about augmented reality. So we're going to leave one silly app about toy soldiers behind and move on to another, hopefully. So what is augmented reality? Augmented reality is putting information and overlaying it over the real world, digital information, and trying to look at it, use it to augment your view of the world, or the way you hear the world in some cases. So some examples here, your classic thing like the IKEA app, which lets you place furniture around your room by looking through your phone. But it goes on far more than that. And the best example that I like to give is at the British Library, there's a statue of Isambard King de Brunel within the grounds but outside with a QR code on it. You scan that QR code and Isambard King de Brunel starts talking to you through the speaker on your phone. And you stood there in front of this statue of this guy who's been dead for years and years and years, and listening to him talk, obviously a voice actor, but you get, you're going into depth in that experience. It's another good example of augmented reality. But we're talking about React Native, we're talking about mobile phones in this case, so we are going to talk about doing some augmented reality with using the camera on our phones. So I made an app which was to, again, help me playing a board game, and this board game happens to use this lovely hex grid. And I thought it'd be really cool if I could allow a user to interact with this on a digital level, maybe to select which hexes that they were interested in, or plan out their moves beforehand using their phone, and think about some different mechanics in the game, and even potentially develop whole new games that are really kind of partially digital, partially board game. Lofty ideas that will probably never go anywhere. But I thought, okay, so first things first, I need to be able to draw some hexes over this real life board that I've got in front of me. Before you even get there, though, you need to do the hello world of augmented reality, which is putting some text in the air. And finally, I promised you Solomon, and here is Solomon sleeping in a cardboard box, obviously, rather than the expensive cat bed that we bought for him. And realistically there, what I'm doing is just putting some text, a half meter up in front of me. But let's have a look at what that looks like in code. So I used a library called Viro to do this because I didn't want to have to use the various libraries for iOS and Android specifically. And actually Viro, I think they recently went from a model where you have to get a license and an API key to being a bit more open source and free, which is kind of cool. So definitely recommend checking it out if you're interested. Once the library has initialized, we kind of have this idea of tracking being updated to say, and you saw in that video there was kind of, the text was a bit flickering around and then it settled. So with a lot of augmented reality applications, you'll find that they are literally tracking their surroundings, looking for flat surfaces, looking to ground themselves, and looking to start detecting planes and things like that. And so I'm just setting the state and changing this text to say meow once I've done that. And I'm positioning that text, again, just like a meter up in front of me. So I had to be stood in the right place for it to say meow over the cat. That code is not valid. There's no closing tag for that Viro text. I'm sorry. But the principle is there. So we can put some text in the air. So let's take that a step further and go, okay, let's detect these images. Let's find these hexagons and start drawing on top of them. And you'd think that actually detecting a simple image would be the way to go, to be able to, because that's how we work as humans. We see a simple pattern and we can spot it around the place. But actually for computers, a much more complicated image is much easier for it to find because it's a unique thing in the field of vision of the camera for it to find. So in this example here, I want to find this mad little hat from a coaster on my coffee table, rather than looking for the individual hexagons shapes in that board. So this was kind of my first attempt of taking that board and looking at it and going, okay, draw a hex just in this position. Because once I know where the board is, I know where the hexes are in it. So I'm kind of laying over information I know into this. And then once you can do that, you can do all sorts of fun things like going, okay, well, we can start animating these hexagons, we can start having entry animations when we detect the borders in our vision, and then you can start to get interactions where someone's tapping on one of those and starting to have some fun with that. I'm just going to play that one again because the most interesting part of it is at the very beginning of the animation as everything kind of flips in. And you can see how quickly that happens. It's as soon as it detects that image in focus. So let's have a look at some code for this. I'm literally saying to the library, hey, here's an image, and this is how wide it is. And I want you to keep an eye out and look for that image. So I'm saying here the image is 40 centimeters wide. Oh no, actually 4 centimeters wide because this code is for the little hat that was on a coaster. So 4 centimeters wide, and that gives it an idea of when it detects that image, also how far away that object is or that plane is. And then I'm registering that in the code here to say when the target of hat, which is the image that I've registered with you earlier, comes up, in this case I'm saying draw a box of that size at that point, 5 centimeters or 50 centimeters, 5 centimeters in this case, above that image. And I'm applying exactly the same logic when I'm drawing all those hexagons and having them animate in and things like that. There's a whole animations library that's built into Viro React, works in a very similar way to how I'm registering the image there. You register animations that you can then call on the various objects. And you start to realize that something that you think of as being quite tough to do in a language like JavaScript or in a paradigm like React Native, you think augmented reality, that must need some intense 3D processing, things like that. Actually, no, that's all being done by libraries that we're being exposed to. And a declarative format like the React syntax, like JSX, is really good for saying, hey, when you see this image, draw something on top of it. So it's a really convenient kind of paradigm to work in. If you are interested in talking about this some more, you can check me out on GitHub. I don't really do Twitter, sorry. But yeah, try and look at React Native from a different perspective. If you get the chance, I really encourage you to have some fun, look out there at what you can do that's a bit more off the beaten path, and then come up here and tell me all about the fun you've had. Just a quick plug, because I work for a company called Anaplan, as I said at the beginning. We are hiring, we're always hiring. This is just a quick selection of jobs. You can find a full list of jobs that we've got open at the moment at boards.greenhouse.io/Anaplan. And we are looking for React Native developers at the moment. So please get in touch if you're interested. So the question was, did I look at using the native driver when doing animations? Yeah, for some of the animations there, I could have explicitly set it up to use the native driver. It's effectively adding an extra argument when setting up the animated timing, for example. It only works on certain properties, it's worth noting. And it works a lot better if you're using the translations part of the animations API. I didn't need to include it in the code samples was the short answer.
Your code.
So the
Translation.
Yeah, the question was, can you actually animate the height and the width of a native component? And actually, yes, you can adjust the certain properties, certain style props that are not part of the translation, and height is one of those. Also, the position, so your top, your left, your right, your bottom, but it isn't as effective as using the translations. So the question is around the algorithm that's being used to match the images in the augmented reality work. I'll be honest, I don't know. It will likely be whatever ARKit and ARCore are using for their native image matching. So, because realistically, Viro AR is really just a library that's interfacing with the native libraries that are being used, and they do provide their own ways of doing that. I think you can pick the algorithm you want when using ARKit, but I've not used it directly myself. My Objective-C in Swift is terrible. Well, if there isn't anything else, I'll hand you back over.